Tattoos. They're art, there are stories etched right into our skin. But have you ever really stopped to think about the science of it all? I mean, how in the world does ink stay sharp for a lifetime on an organ that's literally always renewing itself? Well, the answer isn't magic. It's this incredible dance between physics and biology.
So here's the big puzzle, right? Our skin is constantly regenerating. That outer layer, the epidermis, it completely swaps itself out about every month. So for a tattoo to have any chance of lasting, the ink has to go deeper than that. But how does it manage to just stay put for decades, completely defying this constant biological churn?
The solution to this paradox? Well, it's not just one thing. It's actually a brilliant feat of microscopic engineering. It's a really precise collaboration between the artist's tool and, believe it or not, your own immune system.
So where does this incredible engineering actually begin? It all starts at the very first point of contact, the needle. And it's not just some sharp pin, it's a precision instrument, and its specific design literally changes everything.
Okay, so let's zoom in and look at the geometry of that needle, because it's right here, in the tiniest details of its shape, that the foundation for a sharp, permanent tattoo is either perfectly laid or, honestly, completely ruined from the start. At the heart of all this is a choice the artist makes. Are they using a long taper or a short taper needle? Think of a long taper needle like a surgeon's scalpel. It's long, it's slender, and it slices into the skin with almost no resistance, creating a super clean wound. A short taper, though, that's more like a chisel. It's shorter, it's blunter, and it has to basically punch its way into the skin with a whole lot more force.
So when you use that long taper, that scalpel, you're creating these tiny, perfect, clean channels in the skin with very little collateral damage. What that means is less swelling, way faster healing. And this is the key part. That narrow wound helps to literally lock the ink particles deep down in the dermis, which is exactly where they need to be.
But the short taper, that's a whole different story. It's acting with blunt force. It creates a much wider, more traumatic wound, which causes a lot more cell death all around the puncture site. This forces your body into a much bigger, much longer inflammatory response just to clean up all the mess. And that trauma, it's not just on the surface, it's happening at the cellular level.
And that cellular trauma, it sets off a biological clock. The first 96 hours, that's just 4 days, are absolutely critical. And the type of wound that needle created dictates the entire healing process from that moment on.
Your body's response is immediate. In the first couple of hours, it's all about stopping the bleeding. Then, for the next day or so, immune cells rush in to sanitize the area. But by day 4, we hit this crucial moment, the peak of inflammation. Now, with a clean puncture from a long taper, this is a totally controlled process. But with the blunt force trauma from a short taper, the body can just freak out, triggering a hyperinflammatory response that can actually lead to permanent scarring.
Okay, so now we get to the most incredible biological trick that makes tattoos permanent in the first place. As it turns out, your own immune system holds the secret. It doesn't fight the ink, no, it becomes its lifelong guardian. And it all comes down to this one action, phagocytose. It's a fancy word, I know, but it literally means to devour a cell. In this case, your immune cells, these specific ones called macrophages, see the ink particles as foreign invaders, and one by one, they eat them. This process kicks off this absolutely remarkable cycle. So first, macrophages rush in and capture the ink. They hold on to that pigment for their entire life. Then, when they eventually die, they release the ink. But, and here's the genius part, a brand new, neighboring macrophage instantly swoops in and recaptures it. It's like a microscopic relay race, passing the ink from one generation of cells to the next, forever. But here's the catch. For that relay race to actually work, the runners need a clean track to run on. A precise, clean puncture from a long taper needle gives them that perfect, smooth surface. But the scarring and damage from a short taper, that just destroys the track. It creates a chaotic, damaged environment where that cellular handoff can totally fail. And what happens when that recapture fails? Well, the ink particles are suddenly on their own. They start to just drift through the tissue. And what's the visual result of that drift over time? That's it. Those are the blurry, fuzzy, blown-out lines we've all seen on older, maybe not so great tattoos. The initial trauma sets the stage for the long-term clarity. So, this brings us all the way back, full circle, connecting all this deep science right back to the artist. Because the real art isn't just the design on paper, it's in the scientific precision of how it's supplied to the skin. There's a great quote from the source material that just sums this up perfectly.
Using a short taper for fine detail on thin skin is like using a hammer for a needle's job. I mean, sure, the artist might get the ink in there, but the collateral damage they cause can absolutely ruin the result over time. So, what's the big takeaway here? It's that a great tattoo is so much more than just having a steady hand. True artistry is having a deep understanding of the physics and biology of the skin. It's knowing exactly which tool to use on which canvas and treating the whole process with almost clinical precision. That's how you create art that truly lasts a lifetime, looking just as crisp on day 1000 as it did on day 1.
It really makes you wonder, doesn't it? If something as seemingly straightforward as a tattoo involves this unbelievable dance of physics and biology, what other simple things in our daily lives are governed by a complex, hidden science that's just waiting for us to understand it?